Hello, this is Professor Baswite. Today we will talk about plotting lines. All right. Now, plotting or graphing lines, this means the same thing. We can use two pieces of information to plot a line. Okay, so if I was to plot a line using two random points, let's assume here's a point and here's another point, and they give me those in ordered pair. I can draw it, and that's all I need. But sometimes I use a third point, like that one I show it like that, and then see if that falls on the same line. So I need two pieces of information to plot a line, but I can use a third one to check whether or not that one falls on the same line. That's the first concept. The second concept, I can use two intercepts to plot a line. Here's one intercept, y-intercept, and here's an x-intercept. Guess what? If I use those two intercepts, I can draw a line. Okay? I don't need a third point. If you want to check a third point at a random point and see if that's on the line, you can do that. But you can use two intercepts to draw a line. All right. Another thing, again, you need two pieces of information to draw a line. Two things. This can be like, for example, y-intercept and a slope. Here's my y-intercept, and then they give you the slope. Let's say they say, okay, I want a slope of 2 to 1. Okay, well, how do you do that? You start with your y-intercept. You have to go up to 1, 2 over 1. Here we go. Put an imaginary point in there, and now you can draw. All right, let's do another one. Let's say my y-intercept is here, and my slope, I'm looking for a negative 3 to 1 slope. You start with your y-intercept. You're going to go negative 3, 1, 2, 3 over 1. So I can draw this line. So I can use a y-intercept and the slope, draw the line, as long as I know where they are. Okay, well, let's try an x-intercept and the slope. Here's my x-intercept. Let's say they are saying, okay, well, draw a 2 to 1 slope from that x-intercept. How do I do that? I go up to 1, 2 over 1 and draw. Okay? Another one. Here we go. Let's say it goes through the x-intercept there, and I want a slope of negative 2 to 1. Okay, what do you do? 1, 2 over 1. Okay, so I can draw the line that way. Or somebody may say, okay, well, have a random point and a slope. Okay, random point, here you go. This one is a random point of 1, 2, 3 over 3, comma 2. And then let's say I want to draw a slope of 2 to 1. Okay, you start with that point. 2 means you're going to go up 1, 2 over 1. Well, let's do another one. Let's say I'm looking for a line that goes through negative 1 and negative 1, and it has a slope of negative 2. Start with negative 1 and negative 1. Here you are. And slope of negative 2 over 1 means you start with here, you go down to 1, 2 over 1, and draw. So this is a line that goes through that point and that has that slope. Okay, putting it all together. I think I pushed something. Well, I'll just leave it in there. I don't quite know what. All right. Let me try this. Oops, I'm making it worse. Okay, I cannot get rid of it. Okay, let's leave it there. 3, 1, undefined slope. So if I'm looking for a point 3, 1, 1, 2, 3, and 1, and it has an undefined slope, how do I draw that? I know that the undefined slope is vertical, so I can draw a line that goes through 3 and 1, and it has an undefined slope. Let's try another one. -2, -3, and it has 0 slope. -2, -3, this is 1, 2, 3. -2 means here to the left, and -3 means down. Here's my point. I'm doing that one. And 0 slope. What does 0 slope means? Just the horizontal line. Okay, let me do this one dotted red. 0, 3, and what did they give me? They gave me 0, 3, they gave me the y-intercept. And slope of 1, how do I draw that? Go up 1 and over 1. Here is my line. Okay, dotted line. -2, 0. That one, let's do that in green, dotted. -2, 0 means 1, 2, and then no y, okay? And slope of 1/2. How do I do that? Go up 1 over 2, 1, 2. And I'll do that dotted green. Okay? Do you see it? I used an x-intercept, I used the y-intercept, I used random points, I did positive, negative, undefined, and 0 slopes. Okay. Now, the next step, they may give you an equation in the standard form and graphing it from an equation, intercept method. So what that means is a bit more complex. They are telling you, okay, well, use the x and y intercepts. Here's my equation, 2x plus 3y equals 6. To find the x-intercept, what do I need to do? Set y to 0. Now put y to 0 in there. I have 2x equals 6. That means x equals 3. So that means my x-intercept is 3, 0. Go put that in, 1, 2, 3, 0. Here is my x-intercept. And this one is 1, 2, 3. And this one is 1, 2, 3. Because of the pixel situation, I have it to the left a little bit. Just ignore that. Let me do this so that it doesn't confuse you. All right, kind of a thicker axis. All right, let's look at y-intercept. That's when x is 0. Okay, so let's put x0 in there. So you put 2 times 0 plus 3y equals 6. That goes. 3y equals 6, y equals 2. That means 0, 2 is my y-intercept. Let's go 0, 2. Here's my point. And I simply go and draw a line through those two intercepts. So we were doing this conceptually before, and now we did it algebraically. You're given an equation, set y to 0, find x-intercept. Set x to 0, find the y-intercept. Use those 2 points and draw a line. Okay. Now, any 2 points. And remember, the third one is going to be my test points. Just kind of check, make sure that it's on there. So you need to make a little table. And you pick your x and y any which way you want. Okay, but they're not going to be intercepts for whatever reason. Okay, so let's go and let's put x of 1. And you're going to go and calculate your y. 2 times 1 plus 3 times y equals 6. Take that away. 3y equals 6 minus 2, that's 4. Y equals 4/3, which is the same as 1 and 1/3. Okay, so 1 and 1/3. So when it's 1, this is 1 and 1/3. So this is 1, 2, 3. 1, 2, 3. Here's 1 and 1 and 1/3. Around here. That's the first point. Let's do the next point. I'll pick x of 2. Okay, let's plug it in. 2 times 2 plus 3y equals 6. This one gives me 4 plus 3y equals 6. 3y equals 6 over 4, 6 minus 4, which is 2, and y equals 2/3. Okay? All right. When x is 2, y is 2/3. Let me make sure. 4 2/3. That's right. So let's go do that. When it's 2, it is 2/3. 2/3 is kind of hard to show, but it's around here. Now I can actually draw a line at this point. Let's have a checkpoint. Checkpoint is the third one that you just want to make sure is good. So let's do, I don't know, x of 3 or something. So I'm going to check that. It should be around there. So 2 times 3 plus 3y equals 6. And this one is 6 plus 3y equals 6. And guess what? Y equals 0. Okay? This is close enough, but I'm not quite sure. But 3, 0, and that looks like an intercept, and it looks close enough. Okay? If you are in doubt, check it with another point and make sure that you drew the right line. Okay. How do I draw some special cases? X equals 4. Okay, what does that mean? X is 4 no matter what y is. Well, let's pick a y, 0. X is 4 no matter what y is. Where's 4, 0? 1, 2, 3, 4, 0. And what is 4, 1? 1, 2, 3, 4, 1. Oh, look what we got. When y is no matter what and x is a fixed number, I get a vertical line. So x equals something is always a vertical line. That's good to know. Okay, next one, y equals 4. Okay, what's that mean? Y is 4 no matter what I pick for x. Let's pick 0 and 1. 0, 4 means 1, 2, 3, 4 here. And 1, 4 means 1, 2, 3, 4 here. What do I get? Guess what? I get a horizontal line. That's good to know. Y equals something is always a horizontal line. Okay, y equals x, that's another special case. That kind of looks different. What's that mean? That means I pick an x and then plug it in and find the y. I pick another x and I plug it in, I find y. Look how it is. 1, 1, 2, 2, and 3, 3 if you want the third to check. Zero, 0. So it is a line. This one is a little bit shifted, but it's a 45-degree line. You don't see the 45 degree, you see a little bit smaller degree because this is larger than that, that's why. But it is actually a 45-degree line when you have y equals x. Let's look at another special one. Y equals negative x. Okay, let's make a table. I pick 0, y will be 0, 0 equals 0. Let's pick 1, y equals negative of that, which is negative 1. A third one to check, 2, negative 2. Let's put that. It has to go 0, 0. 1, negative 1. Here we go. 2, negative 2. Here we go. What do I get? Again, I find something, it's going 45 degree the other way, and it's going to look like that if you had these two scales matching. So it is a 45-degree line going down. So these are kind of special cases, and we started playing with this, and we're going to do more with the equations in a minute.